let's do another example, but let's go ahead and split this one up into two pieces. So I like to first question parameterize the surface, capital S, which is the parallelogram shown below. So what we have, let's just draw the parallelogram first. Okay, this parallelogram lives in three-dimensional space, but we're just drawing it on a sheet of paper. The lower, it's weird to even say the lower left corner, but at least in our drawing, the lower left corner has coordinates 1, 9, 5, and the lower right corner 3, 5, 11, and the upper left corner 4, 10, 3, and the upper right corner 6, 6, 9. Now, what I'd like to do is, for our answer, let's just, redraw the parallelogram and just, for our convenience, wrapping around counterclockwise starting from the lower left corner, call these vertices A, B, C, and D, and then if you compute the vector from A to B, you'll get 2, comma, negative 4, comma, 6. The vector from A to D, so that, okay, this vector, that vector, okay, vector from A to D is 3, comma, 1, comma, negative 2. Now, there's lots of ways to do this, but I just started from one corner and computed the displacement vectors. The reason for doing this is now it should be, there's a bit of geometric stuff and reasoning going on and producing the following parameterization. But what I'd like to have is, how about we just take the coordinates of that lower left corner, so 1, 9, 5. We add on the components of the AB vector with a parameter u, so 2u, then for the y formula a minus 4u, and for the z formula a plus 6u, and then take the components of the other vector and tack this on with a parameter v, so 3v plus 1v minus 2v, and we'll have u going from 0 to 1 and v going from 0 to 1. Okay, so this is an answer that works. There are many other ways to parameterize really practically any shape, but I think there's something very natural about the way this is done. Now we're going to follow this up with another question, but what I'd actually like you to do is to do the following thing. First is, for the interactive question, I'd like you to kind of reverse this. So based on the parameterization, so just based on this parameterization right here, I would like you to compute the 4 vertices of the parallelogram. So what I'm saying is, let's say you were not given this information. Okay, let's just say you were given this information. Then I would like you to just do the arithmetic. I know this sounds silly, but it's meant to help build some geometric intuition for what's going on. But I want you to, based on this alone, and the fact that the parameter domain is this square in the UV plane, so u at its smallest is 0, u at its largest is 1, same story for v, I'd like you to recover and create and see that you get these numbers here. You get the point 1, comma 9, comma 5, you get the point 3, comma 5, comma 11, and so on and so forth. So go through that. Okay, as a follow-up, I'd like to then do the following. So as our follow-up question, based on the parameterization we have above, I'd like to integrate f of x comma y comma z equals the fraction x plus 2y over 3z plus 4 over the capital S that we had over in the previous question. And I'd like to suggest that to practice the key thing, let's only go through the process of setting up get to the point where you've set up an iterated interval. That is, set up a du dv integral or a dv du integral, but do not evaluate. I think we're just too many things that are going on otherwise. So let me actually clean a little bit how the screen is written so that we can work on this. And so I'll move the question up here and erase the previous question, sure, but we have the key result we needed from the previous question, which was this parameterization right there. I would actually invite you to pause and, based on this parameterization, try working on this yourself and see what you come up with, and then unpause. Okay, for me, here is a response to this question. So first, we need the information of the parameterization repackaged as a vector function. So r of u comma v, we're really just looking over here to get this, and we're going to have angle bracket 1 plus 2u plus 3v, comma 9 minus 4u plus v, comma 5 plus 6u minus 2v, and we see that u and v both go from 0 to 1, so we can just borrow that information here, and this information is our parameter domain information, capital D. If we want, we could also write the information about this capital D in, this is a bit more set theory like notation, but all values from 0 to 1, Cartesian product all values from 0 to 1. If we compute the partial derivative of r with respect to u, we should just get 2 comma negative 4 comma 6, and if we compute the partial derivative of r with respect to v, we should just get 3 comma 1 comma negative 2. If we go ahead and compute RU Cartesian product RV, if I have not making any mistakes of taking the cross product of this, sorry, not the Cartesian product, the cross product of this vector and that vector, that should just end up being the vector 2 comma 22 comma 14. Then the double integral over the surface S of f, let's not write the of x comma y comma z, we could, okay, d capital S, this is just meant to recopy what's there. Of course, our f is this function right now, okay, that's going to be equal to the double integral over d, let's go ahead and do that, right? So d we know is just u goes from 0 to 1, v goes from 0 to 1, so why don't we just write 0 to 1, 0 to 1, and then we need to compose f with r. Yeah, so based on this, we should plug in these values there. Okay, so the fraction x plus 2y. So x is going to get replaced with 1 plus 2u plus 3v plus 2 times y, so 2 times the quantity 9 minus 4u plus v. This is all over 3z plus 4, so 3, and then z gets replaced with quantity 5 plus 6u minus 2v, then plus a 4. All right, now we need the magnitude of the cross product. So that should be, well, we have the cross product right there, and we can just, this is a little on the side of lazy, but I hope actually not simplifying makes it easier to spot what's really going on. So we should have root 2 squared plus 22 squared plus 14 squared. And then dA, well, okay, du, dv, or dv, du, it's not going to matter the order because they're both just from 0 to 1. So du, dv. Let's pause there. And if you swap these, we get real lucky in this problem that it's fine as well.